to address the issue of 3,510 Hz interference affecting UPS units, a solution involves installing line noise filters at the UPS input. Line noise filters, also known as electromagnetic interference and radio frequency interference filters, can be installed at the input of each UPS unit to block the 3,510 Hz interference. These filters are specifically designed to attenuate particular frequency ranges, including the 3,510 Hz signal, while allowing the normal alternating current power to pass through. The installation process includes these steps. Firstly, identify the input power cables for each UPS unit. Secondly, install the line noise filter in line with each input power cable. Thirdly, ensure that the filter's frequency range of attenuation includes 3,510 Hz. The benefits of this approach include blocking the 3,510 Hz interference without the need for transformers, which would be more expensive and space-consuming. It also protects the UPS units from voltage spikes and other electrical noise that can cause malfunctions. Moreover, it improves the reliability and performance of the UPS units, preventing unnecessary transfers. Several considerations are important. Use line noise filters that are rated for the appropriate voltage and current draw of the UPS units. Verify that the filters are compatible with the specific UPS models being used. Periodically inspect and maintain the filters to ensure they are functioning properly. Line noise filters, often referred to as electromagnetic interference or radio frequency interference filters, play a crucial role in maintaining the power quality and operational stability of sensitive electronic equipment, particularly UPS units. These filters work by attenuating unwanted high-frequency noise present in the alternating current power supply. This noise can originate from various sources, including radio transmissions, electrical motors, switching power supplies, and other electronic devices. Without proper filtering, this noise can propagate through the power lines and interfere with the operation of electronic equipment, causing malfunctions, data corruption, or even permanent damage. The fundamental principle behind a line noise filter is the use of passive components such as inductors and capacitors arranged in specific configurations to create a low impedance path for the desired alternating current signal while presenting a high impedance to unwanted high-frequency noise. Inductors, which are coils of wire, impede the flow of high-frequency currents due to their inductive reactance, which increases with frequency. Capacitors, on the other hand, provide a low impedance path for high-frequency currents by shunting them to ground. By strategically combining inductors and capacitors, line noise filters can effectively block noise within a specific frequency range, typically from a few kilohertz to several megahertz, while allowing the 50 or 60 Hz alternating current power to pass through with minimal attenuation. There are several types of line noise filters available, each designed for specific applications and noise frequencies. Common mode chokes are used to attenuate common mode noise, which is noise that is present on both the line and neutral conductors with respect to ground. Differential mode filters, on the other hand, are used to attenuate differential mode noise, which is noise that is present between the line and neutral conductors. Some line noise filters combine both common mode and differential mode filtering to provide comprehensive noise attenuation. When selecting a line noise filter for a specific application, it is essential to consider several factors. Firstly, the filter must be rated for the appropriate voltage and current of the equipment being protected. Secondly, the filter's attenuation characteristics, including the cutoff frequency and attenuation level, must be suitable for the specific noise frequencies that need to be blocked. Thirdly, the filter must be compatible with the specific equipment being used and must meet any applicable safety standards or regulatory requirements. Installing line noise filters is generally a straightforward process. The filter is typically installed in line with the power cord of the equipment being protected, close to the equipment's power input. It is essential to follow the manufacturer's instructions carefully and to ensure that the filter is properly grounded to prevent electrical shock hazards. Regular maintenance of line noise filters is essential to ensure their continued effectiveness. This may include inspecting the filter for physical damage, cleaning the filter to remove dust or debris, and testing the filter's attenuation characteristics to verify that it is still performing within specifications. If a filter is found to be damaged or degraded, it should be replaced immediately. In addition to protecting electronic equipment from noise, line noise filters can also improve the overall power quality of an electrical system. By attenuating noise, these filters can reduce harmonic distortion, improve power factor, and prevent voltage fluctuations. This can lead to improved equipment performance, reduced energy consumption, and increased system reliability. In the specific scenario of a college campus with 32 buildings experiencing interference from a 3510 Hz signal generator, the installation of line noise filters at the input of each UPS unit is a practical and effective solution. By blocking the 3510 Hz interference, these filters can prevent UPS transfers, protect sensitive electronic equipment from damage, and improve the overall power quality of the campus electrical system. The selection of appropriate line noise filters, proper installation, and regular maintenance are crucial for ensuring the long-term success of this solution. It is important to emphasize the advantages of using line noise filters over transformers in this application. Transformers, while capable of providing isolation and voltage transformation, are significantly more expensive, bulky, and space-consuming than line noise filters. They also introduce additional losses into the electrical system, which can increase energy consumption and reduce efficiency. Line noise filters, on the other hand, are compact, lightweight, and relatively inexpensive. They introduce minimal losses into the electrical system and provide effective noise attenuation without the need for voltage transformation. The 3510 Hz signal is being injected into the alternating current line to synchronize the clocks. However, this same injected signal is interfering with the operation of the UPS devices. Transformers may not be a practical solution in this case due to the cost of installing one on every UPS system. Instead, let's look at some solutions for the line filter. There are several different types of filter designs available on the market. Firstly, filters come in different configurations. Secondly, filters have different filter characteristics and performance. Thirdly, filters are rated for different voltage and current levels. The filter configuration may vary to be suited for different types of wiring systems. Some filters are designed for single-phase alternating current systems, while others are designed for three-phase alternating current systems. Some filters are designed for delta-connected systems, while others are designed for Y-connected systems. It is important to select the filter configuration that is compatible with the wiring system used in the building. The filters also come in different filter characteristics. Different filters attenuate different frequencies to different levels. The specification to look for is the insertion loss of the filter. The insertion loss is the amount of attenuation that the filter provides at a given frequency. The insertion loss is typically measured in decibels. A higher insertion loss means that a filter provides more attenuation at the frequency. In this case, it is important to select a filter that provides significant attenuation at 3510 Hz. It is also important to consider the voltage and current rating of the filter. The filter must be rated for the voltage and current that it will be exposed to in the application. If the filter is not rated for the voltage and current that it will be exposed to, it could fail. When selecting a filter, it is important to consider the following factors. Firstly, the filter configuration has to be compatible with the wiring system. Secondly, the filter's insertion loss needs to be high at 3510 Hz. Thirdly, a filter's voltage and current ratings must be adequate for the application. The filters need to be properly installed. Firstly, turn off the power to the UPS unit before installing the filter. Secondly, connect the filter in series with the alternating current power cord of the UPS unit. Thirdly, ensure that the filter is properly grounded. After the filter is installed, it is important to test it to make sure that it is working properly. There are several ways to test a filter. One way is to use a spectrum analyzer to measure the amount of attenuation that the filter provides at different frequencies. Another way is to use an oscilloscope to measure the amount of noise that is present in the alternating current power line. If the filter is working properly, it should reduce the amount of noise that is present on the alternating current power line. Filters should be inspected to make sure that they are in good condition. Firstly, check the filter for any physical damage. Secondly, check the filter's connections to make sure that they are tight. Thirdly, check the filter's grounding connection to make sure that it is secure. If a filter is damaged, it should be replaced. In addition to using filters, there are other steps that can be taken to reduce the amount of noise in the alternating current power line. Firstly, ensure that all of the equipment that is connected to the alternating current power line is properly grounded. Secondly, use shielded cables to connect equipment to the alternating current power line. Thirdly, separate noisy equipment from sensitive equipment. The filters are a very important part of ensuring the reliability of the UPS units. By following the steps outlined in this video, you can help to reduce the amount of noise in the alternating current power line and improve the performance of the UPS units. If the UPS unit is a double conversion UPS, the alternating current is converted to direct current, and then the direct current is converted back to alternating current. The double conversion process isolates the output alternating current from any noise on the input alternating current. For a double conversion UPS, the filter is not as critical. However, the filter can still help to reduce the amount of noise that is present in the building's electrical system. If the UPS unit is a line interactive UPS, the alternating current passes directly through the UPS unit. The line interactive UPS only switches to battery power when the alternating current voltage drops below a certain level or when the alternating current frequency changes. For a line interactive UPS, the filter is more critical. The filter helps to reduce the amount of noise that is present on the alternating current power line, which can help to prevent the UPS unit from switching to battery power unnecessarily. If the UPS unit is an offline UPS, the alternating current passes directly through the UPS unit. The offline UPS only switches to battery power when the alternating current voltage drops below a certain level or when the alternating current power fails. For an offline UPS, the filter is most critical. The filter helps to reduce the amount of noise that is present on the alternating current power line, which can help to prevent the UPS unit from switching to battery power unnecessarily. The 3510 Hz signal is a relatively low frequency signal. There are many different types of filters that can be used to attenuate this signal. Some common types of filters include low-pass filters, high-pass filters, band-pass filters, and notch filters. A low-pass filter allows low-frequency signals to pass through while attenuating high-frequency signals. A high-pass filter allows high-frequency signals to pass through while attenuating low-frequency signals. A band-pass filter allows signals within a certain frequency range to pass through while attenuating signals outside of that frequency range. A notch filter attenuates signals within a very narrow frequency range. In this case, a notch filter would be the most appropriate type of filter to use. A notch filter can be designed to specifically attenuate the 3510 Hz signal. There are a few different ways to design a notch filter. One way is to use a passive filter circuit. A passive filter circuit consists of resistors, capacitors, and inductors. Another way to design a notch filter is to use an active filter circuit. An active filter circuit consists of resistors, capacitors, inductors, and active components such as operational amplifiers. Active filter circuits can provide better performance than passive filter circuits, but they are also more complex to design. When selecting a filter for this application, it is important to consider the following factors. Firstly, the filter should provide sufficient attenuation at 3510 Hz. Secondly, the filter should not attenuate the 60 Hz alternating current power signal. Thirdly, the filter should be rated for the voltage and current that it will be exposed to in the application. Once the filter has been selected, it is important to install it properly. The filter should be installed in series with the alternating current power cord of the UPS unit. The filter should also be properly grounded. After the filter has been installed, it is important to test it to make sure that it is working properly. This can be done by using a spectrum analyzer to measure the amount of attenuation that the filter provides at 3510 Hz. One of the other factors is the correct way to bond and ground these filters for safety and performance. A proper ground is needed to shunt the noise to ground. The grounding conductor needs to be large enough to handle any fault current.